Have you ever start to wonder why a paperclip just bends, but a glass shatters into a million pieces? It's kind of weird, right? Well, every single object around us has this secret story, this hidden set of rules that tells it exactly how to behave. So today, we're going to learn how to read those stories and really understand the science behind all the stuff we use every day.
All right, let's kick things off with a little puzzle. What on earth could a giant steel beam, the kind holding up a skyscraper, have in common with a simple rubber band? I mean, at first glance, they seem like total opposites, don't they?
Well, it turns out the answer is that they both have a unique story about how they deal with all the pushes and pulls of the world. We're about to learn the language of materials. Think of it like decoding their personalities, or, as scientists call them, their mechanical properties.
Okay, first up, let's talk about materials that can be permanently reshaped. These are kind of like the transformers of the material world. They can be stretched, squashed, and changed into completely new forms without actually breaking. Just think about the wiring that's probably inside the walls of your house right now. It's almost always made of copper. And there's a really good reason for that. See, copper has this one special talent that makes it absolutely perfect for the job. And that talent? It's called ductility. Ductility is just a fancy word for the ability of a material to be stretched or pulled into a thin wire. Copper is incredibly ductile, and that's what lets us make the thousands and thousands of miles of wiring that power our entire world. Now, let's switch gears to something a little more glamorous. Gold leaf. You've seen this stuff, right? It's that super, super thin gold used on picture frames or even fancy desserts. Its existence is all thanks to a property that's basically ductility's close cousin. And that property is called malleability, the ability to be hammered or rolled into incredibly thin sheets. And get this, gold is the most malleable metal we know of. You can take a single gram of it, that's about the weight of a paperclip, and hammer it into a sheet that covers an entire square meter. So, easy way to remember, ductility is for pulling into wires, malleability is for pressing into sheets. But not all materials are cool with being permanently reshaped. Some will fight back and snap right into place, while others, well, they just give up and shatter. This brings us to a really fundamental question. When you push on something, will it bend or will it break?
And we're back to our good old friend, the rubber band. We all know the deal with these. You can stretch it, you can twist it, you can totally deform it, but the second you let go, snap. It goes right back to how it was.
This whole bouncing back thing is known as elasticity. It's the property that allows a material to return to its original shape after you stop pulling or pushing on it. It's almost like it has a memory of its original form and it really, really wants to get back there. And now for the complete opposite. Think about a glass window or maybe a ceramic plate. If you try to bend it, even just a little bit too much, you don't get that bounce back. You get a mess.
This is what we call brittleness. A brittle material doesn't really bend or stretch when it's stressed out. It just fractures. It doesn't give you any warning. It just breaks completely.
So here you can see these two ideas side by side. On one hand, you've got elasticity, which is all about returning to normal. And on the other, you have brittleness, which is all about fracturing. A rubber band is elastic. A piece of glass is brittle. Pretty clear opposites, right? All right, for our last section, let's talk about the heavyweights. These are the properties that define how material really stands its ground and resists different kinds of attack. This is all about what you might just call toughness.
Let's circle back to that steel beam from our first question. Its entire job, its whole reason for being, is to handle incredible amounts of weight and force without failing. It has to resist being literally pulled apart.
And that is what we call strength. Specifically, steel has amazing tensile strength. Its ability to resist being pulled apart without breaking. It's the single most important property keeping our bridges up and our buildings standing tall. But strength isn't the only kind of toughness out there. What about a diamond? Everyone knows it's the hardest natural material. But what does hard actually mean in a scientific sense?
See, hardness isn't about being pulled apart. It's all about resisting damage to its surface. A material's hardness is its ability to stand up to being scratched or dented. That's why a diamond can so easily scratch glass. It is just way, way harder.
Okay, one last one. Let's look at another hero of construction, the concrete beam. Its main job isn't about resisting being pulled apart or even scratched.
It's built to resist something else entirely.
And that thing is bending. Stiffness is how well a material resists changing its shape when a force is applied. A thick concrete beam is incredibly stiff. It's not going to sag under a heavy load, which makes it perfect for something like a foundation. So let's just quickly break this down. Strength is all about resisting being pulled apart. Hardness is about resisting scratches on the surface, and stiffness is about resisting bending. We might call all three of these materials tough in everyday life, but in the language of science, they are three very, very different things.
See? From the copper wire in your wall to the glass screen you're watching this on, these hidden properties are at work all around us all the time. They are literally shaping the world we build and live in every single day.
Okay, let's do a super quick fire recap just to lock it in. Ductility, pulled into wires. Malleability, hammered into sheets. Elasticity, it bounces back. Brittleness, it shatters. And the power trio, strength resists breaking, hardness resists scratching, and stiffness resists bending. 7 properties, 7 secret stories.
So now that you know the language, I'm going to leave you with one final thought. Just look at whatever object is closest to you right now. Your phone, a coffee mug, your desk. What's its secret story? What properties define it? And why was it made that way? The world is just filled with these stories, and now you have the key to unlock them.